Hello, good morning. In the previous class, we have worked out a problem on Thevenin's theorem halfway through. So we have just found out Thevenin equivalent voltage by applying KVL to the loop, and the equations we have already solved it. So you can just revise it applying KVL to the loop. The equation that I have written 20 minus 6i, this is minus to plus, so it is 2i, again minus plus to minus, so it is minus 6i equal to 0. You have only one variable there, which is I. Finding out I, it is giving you the value equal to 2 amperes, and then later on we have found out the Thevenin's equivalent voltage between the terminals A and B, which is nothing but the voltage drop across 6 ohm resistor. So it is 6 into the current that we have calculated just now, which is equal to 2 amperes. Next, we need to find out Thevenin's equivalent resistance. For that, let me have the same circuit again on the board. Writing the same circuit, so we have 6 ohm resistor here, this is the current I, and here it is 2i, and the value of this resistance is 6 ohms, and the value of the voltage here is 20 volts. Then we have 10 ohm resistor here, and between these two terminals we have to find out Thevenin's equivalent network. So these are the terminals A and B here. So now since we have a dependent source in the network here, we cannot apply the same rule as we have applied in the previous case. That means we cannot reduce the voltage sources to 0, or we cannot replace it by its equivalent resistance. Rather, we have to go for the second rule, wherein we have to find out the short circuit current. So what is the short circuit current? Just short the terminals A and B and find out the current that is flowing through that, which we represent it as ISC. So in order to find out this current, once again we have two meshes here. Write the mesh equation and solve for the current ISC here. So in order to write the mesh currents, let us assume the two meshes I1 and I2. Mesh currents I1 and I2. So now we can write the equation by applying KVL to both the meshes 1 and 2. So in the mesh 1, I have 20 volt source, 6 ohm resistor, a dependent source, the value of which is 2i, and a 6 ohm resistor. The I value is nothing but the current that is flowing through 6 ohm resistor. So that what is the current flowing through 6 ohm resistor? If you just observe the assumed currents I1 and I2, the current I flowing through 6 ohm resistor is nothing but equal to I1 minus I2. So write I1 minus I2 is I. So next, write KVL for mesh 1 as well as mesh 2. So applying KVL and writing the equation here, we get 20, which is the potential rise and hence the positive sign, minus 6 I1, because the current flows from higher potential to lower potential and hence a drop, and for the dependent source minus 2 plus, which is the rise. So write plus 2i, and for the resistor of 6 ohm resistor here, the drop, because the current flows from higher potential to lower potential. So write it is minus 6. The currents that are flowing through 6 ohm resistor is I1 minus I2. So it is 6 into I1 minus I2 equal to 0. So further simplifying it, we are going to get it as 20 minus 6 I1 minus 6 I1, it is 12 I1, and for 2i, for I here substitute I1 minus I2. So plus 2 into I1 minus I2, okay, then minus into minus is plus 6 I2 equal to 0. That's the second equation we can write. So now simplifying it further, I get 20 minus 12 I1 plus 2 I1 minus 2 I2 plus 6 I2. so that I can write the equation in terms of I1 and I2. I am going to get it as 20 minus 12 I1 plus 2 I1 is minus 10 I1 minus 2 I2 plus 6 I2 is plus 4 I2 is equal to 0. Or I can write this as 10 I1 minus 4 I2 equal to 20. That means shifting the minus 10 I1 plus 4 I2 to the right hand side, we get this equation. So, it is 10 I1 minus 4 I2 equal to 20. Call this equation 1. Then coming to the second part here, that is the second loop, I can write the equation as 6 I2 minus I1, 6 I2, because I am writing the equation for the second mesh and hence I2 will be greater than I1. So, it is 6 I2 minus I1 plus 10 I2 equal to 0, plus 10 I2 equal to 0. I am just considering the drops here. So, plus to minus, though it has a negative sign, when it is transferred to the right hand side, it is going to become plus. And simplifying it further, I am going to get this as minus 6 I1 plus 16 I2 is equal to 0. So, this is the second equation. So, we can solve the equation 1 and 2. Solving equation 1 and 2, we have to find out the value of I2, which is nothing but equal to ISC, the value of which we can find out by taking the value which is equal to 0.8823 amperes. So, ISC value is 0.8823 amperes. So, after finding the value of ISC, we can find out R Thevenin, which is equal to V open circuit by I short circuit. V open circuit value is equal to 12 and I short circuit value is 0.8823. So, this is your R Thevenin value. This is the value of R Thevenin. So, similarly, we can try solving the different problems over here. For that, let us go to the next problem. So, we have different problems to work out in this case. Let us first consider the first problem. Obtain the Thevenin's equivalent of the network shown between the terminals X and Y, and you also have to find out what is the value of V0. So, actually basically you have to find out, in this particular case, you have to find out the voltage across 2 kilo ohm resistor by applying Thevenin's theorem. So, for that, since we have to find out the voltage across 2 kilo ohm resistor by applying Thevenin's theorem, we need to remove the resistance 2 kilo ohm from the network. So, coming back to the network here, the same thing. I have 12 volts, then 6 kilo ohm resistor, we have 3 kilo ohm resistor here, then the 4 kilo ohm resistor, and you have a current source which is an ideal current source of 4 milliamperes. Then we need to have 2 kilo ohm resistor, and across which we need to find out the voltage V0 between the terminals X and Y, or you can also call it as A and B, any two terminals we can call it. So, now in this case, can just observe there are two nodes here. this is one node, this is another node, and you can also call this as one more node. There are 3 nodes. So you can consider the nodal analysis to solve this problem, or you can consider mesh analysis to solve this problem. So initially our aim is to find out the voltage V naught, which is nothing but equal to voltage across 2 kilo ohm resistor. You have to find out voltage across 2 kilo ohm resistor, and hence we have to remove the resistance of 2 kilo ohms from the circuit. So removing that, I'll get an equivalent circuit of this kind. So this is the circuit I'm going to have it. So XY is nothing but the voltage between these 2 points, whereas I have eliminated 2 kilo ohm resistor from this circuit, or I have created an open circuit at this point. So now I find only 2 closed paths, one 12 volts, 6 kilo ohm and 3 kilo ohm, the other one having 6 kilo ohm, 4 kilo ohm and 4 milliamperes. And according to super mesh analysis, if I call this as current I1 and this is current I2, then according to the super mesh analysis, the current I2 is nothing but equal to 4 milliamperes. I2 is equal to 4 milliamperes because I have an ideal current source in this loop, okay, and since I am having it, I can just equate this current I2 equal to 4 milliamperes. This is by applying super mesh analysis. So then I have only one loop left with, for which I need to write the equation. So writing the equation for the second mesh, I am going to get it as 12 volts or 12, which is 12 minus 6 kilo into the 2 currents are flowing through that, which is I1 and I2. So it is 6K into I1 minus I2, and then through 3 kilo ohm resistor I have only the current I1 which is flowing. So I write minus 3 kilo I1 is equal to 0. I know the value of current I2 already, which is equal to 4 milliamperes. So that I can write here 12 minus the I1 values are 6K I1 and 3K I1, both having the negative sign. So that I can combine it together and write it as minus 9K I1. I have the value there. And then for I2, it is minus into minus plus 6K I2 is equal to 0. So we can substitute the value of I2 equal to 4 milliamperes in this equation, so that I get 12 plus 6K into 4 milli. So K gets cancelled with milli, so that I am going to get 6 into 4, which is nothing but equal to 24. 24 plus 2, which is equal to 36. Okay. So 36 is equal to 9 I1. That's what I am going to get. 9K I1. 36, that is 24 plus 12, which is equal to 36. 36 on one side and 9K I1 on the other side, so that I can find out what is I1 equal to. So I1 is equal to 36 divided by 9K. 36 divided by 9K. So it is 4 milliamperes. The value of current flowing through 3 kilo ohm resistor is 4 milliamperes. So now our aim is to find out the voltage between the terminals X and Y. So since we have to find out the voltage between the terminals X and Y, just apply KVL and find out what is it equal to. So actually the current I1 is flowing in the downward direction through 3 kilo ohm resistor. So write plus and minus, and in this case I2 is flowing, the direction that I have chosen here is like this, so it must be plus and minus. So now minus to plus, the addition of these two voltages must be equal to, or addition of the drop across 3 kilo ohm resistor and 4 kilo ohm resistor must be equal to the Thevenin's equivalent voltage V naught. So V naught or V Thevenin is equal to 3K into 4 or 3K into I1 minus 2 plus. So, it is plus again plus 4K into I2. The current that is flowing through 4 kilo ohm resistor is I2. We know that I1 is equal to 4 milliampere and I2 equal to 4 milliamperes. Substitute the values there. 3K into 4 milliampere plus 4K into 4 milliamperes. So, totally it is 12 plus 16 or it is equal to 28 volts. So, Thevenin's equivalent voltage will be equal to 28 volts. The next step is to find out the Thevenin's equivalent resistance. In order to find out Thevenin's equivalent resistance, look at the circuit here. This is a normal circuit wherein you have only the ideal voltage source and the ideal current source. We do not have any dependent voltage source or dependent current source in this network. Since we have independent sources, replace the voltage source by the short and the current source by an open circuit. By having done that, I get a circuit which is equal to or which is nothing but equal to 12 volt source, I am shorting it, and this current source I am opening. So, this is the thing. I have here 6 kilo ohm resistor and 4 kilo ohm resistor, again 3 kilo ohm resistor here. Okay. So, looking at that, this is an open circuit. Now, once again, to find out the equivalent resistance, looking into the circuit from the output terminals X and Y, that means sending a current at this point, you just see here that current when it tries to flow through, because it is an open circuit, no current flows through that path, only the same current flows through 4 kilo ohm resistor here. Then that current, after passing through 4 kilo ohm, it finds two paths at this particular node, one through 3 kilo ohm resistance, the other one through 6 kilo ohm resistance. So, that we can deduce that 3 kilo ohm and 4 kilo ohm resistor are in 3 kilo and 6 kilo ohm resistors are in parallel, together they are in series with 4 kilo ohm resistance. So, that you can write R Thevenin is equal to 3K into 6K divided by 9K, 6 plus 3, that plus 4K. That is Thevenin's equivalent impedance R. It is 2K, 3K into 6K by 9K must be equal to 2K plus 4K, 4 kilo ohms, or it is equal to 6 kilo ohms. So, now I have got Thevenin's equivalent voltage which is equal to 28 volts and Thevenin's equivalent resistance which is equal to 6 kilo ohms. So, after finding the values of Thevenin's equivalent voltage and the Thevenin's equivalent resistance, replace the existing circuit, the earlier circuit, by Thevenin's equivalent circuit, which is nothing but equal to the Thevenin's equivalent voltage, the value of which is 28 volts, and the Thevenin's equivalent resistance which is equal to 6 kilo ohms, and to that you have to connect 2 kilo ohm resistor in series. It is 2 kilo ohm resistor in series. So, what is the aim of this problem? We need to find out the drop across this 2 kilo ohm resistor by applying Thevenin's theorem. That means, I need to find the current through 2 kilo ohm resistor. That current multiplied with 2 kilo ohm resistor gives me the value of the voltage V0. So, for that just apply Ohm's law here and find the current, and the current here will be equal to I, which is equal to 28 divided by 6 plus 6K plus 2K, which is equal to 8K. So, that is the value of the current. Then V0, that is voltage between the terminals X and Y. The same thing we have reproduced here, but by replacing the circuit behind 2 kilo ohm resistor by Thevenin's equivalent circuit. That is all. So, the same circuit we have it here. Find out V0, which is equal to I into 2 kilo ohm resistor, or it is 28 by 8K into 2 kilo. So, this 2K, if you cancel it, it is 4, and finally the voltage that I am going to get here is 7 volts. So, the voltage V0 between the terminals X and Y must be equal to 7 volts. So, the answers I have, you can just get it. It is 28 volts and 6 kilo ohms for Thevenin's equivalent voltage and the Thevenin's equivalent impedance. But since we have to find out the voltage across 2 kilo ohm resistor, the value we have found out just now, which is equal to 7 volts. So, now on similar grounds, we next move to the next problem. Let me go to the problem number 4 immediately, because we need to find out how we can apply Thevenin's equivalent circuit if a circuit is given which is complicated of this kind. So, let us just try to move to that particular circuit. So, it is problem number 4, and in the problem number 4 I have a circuit with only the resistors. You can just observe, it is 8 ohms, 4 ohms, and here I am having 12 ohms. Then again here it is 12 ohm resistor. Then I have a 34 ohm resistor here and a 10 ohm resistor here. Then again 30 ohm resistor. The value there is again 30 ohms, and these values are, one is 17 ohms, the other one is 13 ohms, and the voltage source is connected between the point over here and then one more point here. These are the 2 points between which the voltage source is connected. Okay. So, the value here is given as 180 volts. The value of the voltage source is 180 volts. That means, if you replace this by a voltage source, the value, it is connected like this. This is 180 volts source plus and minus. This is the network given in the problem. So, according to the problem statement, we have to find out the current through 10 ohms resistor by applying Thevenin's theorem. So, then if we have to find out the current through 10 ohms resistance, the first step is to remove the resistance of 10 ohms from the circuit. So, remove 10 ohm resistor from the circuit. So, removing 10 ohm resistor from the circuit, I am creating an open circuit here. That is one thing. Then coming back to this, anyway, this is the source connected. At this point, if you observe the current division itself, the current divides between 8 ohm and 12 ohm here. The same the same current which is flowing through 8 ohms resistor also flows through 4 ohm resistor. So, that I can replace 8 and 4, which is a series combination, by a series resistance of 12 ohms like this. 12 ohms like this. Then similarly, if you just observe here, a current that enters at this point gets divided between these two, and again the current which is flowing through 17 ohms, the same current flows through 13 ohms because there won't be any branching here. So, that we can say 17 ohms and 13 ohms resistors are connected in series. So, that this resistance also I can replace it by its series equivalent, which is equal to 30 ohms. Now, you can just observe the circuit. It is 12 ohms, 12 ohms, 12 ohms, which is forming a delta circuit. Again here 30 ohms, 30 ohms and 30 ohms, which is a delta circuit. So, in order to simplify this circuit, we have to go for circuit reduction method, where in that case this delta should be converted into star. So, converting this delta into star, how we can do it? I'm just representing it with the dotted lines here. So these are the resistances I am going to get it here. Similarly here also I am going to get with the dotted lines whatever I am representing. So these are the resistance. So what is the value of this resistance? Since all the three resistance values of delta connected network are same, if I find out the value of one of the star element, the same thing will be there for the other two star elements also. So then how to find out the equivalent resistance here? Star to delta, if I do it, you know that the star element, the value of this is nothing but equal to the product of the two adjacent arms of delta divided by sum of the impedances or the resistances of the delta network. So product of the adjacent arms are nothing but equal to 12 into 12 is the product, and if you take the sum of all the three resistances, it is 12 plus 12 plus 12, which is equal to 36. So 12 3s are, so the value of this is equal to 4 ohms. So each element of the star connected network here is having the value equal to 4 ohms. Coming back to the 30 ohms resistors connected in delta, similar procedure, you have to find out the element of star here. It's nothing but the product of the adjacent arms divided by sum of all the three resistances, so that it must be 30 into 30 divided by the sum of all the three, 30 plus 30 plus 30, it is 90. So that you are going to find it as 10 ohms. So now the same circuit I am going to replace it by its equivalent star connected network. So this 12 ohms and all I am eliminating. All these 12 ohms resistors here will be eliminated, and I have only the star connected network wherein all the resistor values are 4 ohms each. So this is 4 ohms, this is 4 ohms, and this is also equal to 4 ohms. Similarly here, if I replace these 30 ohms resistances of delta by its star equivalent, I find it as 10 ohms, 10 ohms and one more 10 ohms here. So this is the network I am going to have. 10 ohms and 10 ohms. So this is the circuit. You can also observe that this 10 ohms and 4 ohms are, if I just send a current through this, the current, if I send a current I, it divides between the two paths. So that is one current through this, the other current through this. But what is happening here is I have only one path here, because this is an open circuit. So that what is the value of resistance in that particular path? So you can just observe, you have 4 ohms resistor, 4 ohm, 34, 10 and 10, they are in series. That is across 180 volts, 180 volts source. So once you find out the current through that, the voltage drop across 4, 34 and 10. This is the voltage. Actually the voltage I have to find between these 2 points. That is my VThevenin. So first find out the current through the network, that is current which is flowing through 4 ohms, 34, 10 and 10, because this is an open circuit, so no current flows through it. So find out the current I, which is equal to 180 divided by 4 plus 4, 8, 8 plus 34, 42 plus 10, 52 plus 10, 62. So once again, 4 plus 4, 8, 8 plus 34, 42 plus 10 plus 10, 42, 52 and 62. So, the value of the current I is equal to 180 by 62. So, after finding this, you have to find out the value of the voltage V Thevenin. This is the value V open circuit voltage or V Thevenin voltage. So, then V Thevenin is equal to, the value of V Thevenin is equal to this current 180 by 62 multiplied with, what are the values of the resistances I am having? 34 plus 4, 38 plus 10, 48. So, it is into 48. So, that is my V Thevenin voltage. Once again 34 plus 10, 44 plus 4, 48. So, that is going to be my V Thevenin value. So, after finding V Thevenin, next step is to find out R Thevenin. To find out R Thevenin, you have to find out, or you have to replace the source, voltage source by its equivalent resistance or by its internal resistance, or if it is not having any internal resistance, replace it by a short. So, to find R Thevenin, I am replacing this 180 volt source by a short. So, it is a short. So, then I need to find out the resistance between the terminals. If I mark these two terminals as A and B, between the terminals A and B, if I mark them as A and B, I have to find out the resistance between the terminals A and B here. So, now once again the same thing, if I send a current at this point, it gets divided between these two paths, like this. So, the same current flows through 10 ohm resistor and again it divides between these two. So, that means 10 and 4, they are in series. So, now writing the circuit, an equivalent circuit here with 10 and 4 in series, I can write the circuit as 10 and 4. So, it is 14 ohms which is connected in series, and I can also write between the terminals A and B how the things are going to happen. This is 14 ohms resistance that is in. So, I can just write 14 ohms resistance here. Then after that 34 plus 10 plus 4, it is 34 plus 4 is 38 plus 10, 48 ohms resistance here, 48 ohms resistance at this point, and then I am having here 4 ohms, and again at this point I am having 10 ohms, and this is the connection. This is the connection between the terminals A and B. I have to find out. So, 4, this is 14 and then 48. So, then I can write between 48, between the same two terminals here, I find 14 ohm resistor also. So, that I can write 48 and 14, or else I can represent it like this. So, instead of writing, I can also write it like this. This is 14 ohms. So, I can just observe 48 ohms and 14 ohms are connected in parallel together. They are in series with these two elements. So, that my R Thevenin value is equal to 48 in parallel with 14 ohms resistor, that is in series with again 14 ohms, 10 plus 4, 14 ohms. So, that is my R Thevenin value. Once I find out V Thevenin value and R Thevenin value, the next step is to find out is to replace the entire circuit by Thevenin's equivalent circuit. So, write the Thevenin's equivalent circuit here, having the Thevenin equivalent voltage equal to 180 into 48 by 62, the value which we have found out, and then the resistance value R Thevenin, which is equal to 48 in parallel with 14 plus 14 ohms. So, that is the value of Thevenin equivalent resistance. then you have to find out the current through 10 ohm resistor, connect the resistance over here. So, it is a simple circuit here, find out the current I through this, which is nothing but equal to Thevenin's equivalent voltage divided by 10 plus R Thevenin. Substitute the value and find out the current, and it is equal to 4 amperes. The value of the current flowing through this circuit is equal to 4 amperes. So, this is the answer for this particular problem. So, next we shall move to the next problem, which is a very simple circuit as such. Go to the problem number 6. Let us try to solve the problem number 6 here. So, problem number 6, the statement once again is to find out the Thevenin's equivalent. You have to find out the Thevenin's equivalent by looking into the circuit from the terminals P and Q. So, P and Q are the terminals they have mentioned there. Once again, it is a DC circuit, and in this circuit I have a source, the value of which is equal to 4 volts, and then the resistance 2 kilo ohm. The resistance 2 kilo ohm. Again, I have a current source, the value of which is Vx by 4000. So, you should understand that though the symbol used here is for the ideal source, since the magnitude of the current source is given as Vx by 4000 here, you should consider, you should treat this, or you should come to a conclusion that this is a dependent source. Then I have one more resistance here, the value of which is equal to 3 kilo ohms, and if you have a dependent voltage source or dependent current source, it is dependent on either voltage or current across any part of the circuit. So, since it is a voltage across any part of the circuit, in this particular case it is Vx by 4000, meaning that the magnitude of the current source is dependent on some voltage Vx. I should represent what is Vx equal to. Vx is nothing but the output voltage itself, and it is marked the points PQ. So, the voltage across PQ is Vx. So, our current source magnitude is dependent on the output voltage Vx here. So, if you find such problems, if you find a problem with the dependent voltage source or the current source, then the very next step is to find out, it is only to find out the Thevenin's equivalent network, and we need not have to find out the current through any load resistance or voltage across any load resistance, and hence we just have to find out the voltage between the points P and Q. It is nothing but the voltage at this point. We have only one node in this particular case. So, you can write the nodal equation and solve the problem over here. So, if you write the nodal equation, you just find only one node here, it is, you just call it as V. Okay. So, if I call this as V and this as the reference, and here is an open circuit as such. So, if I write that, it is V minus 4, because I am writing the nodal equation here. The voltage across 2 kilo ohm resistor divided by the magnitude of 2 kilo ohm resistor is the current. So, that is what I am going to represent here. It is V minus, or I can just write it as Vp, just to understand the voltage here is different from 4V, that is 4 volts. So, let me write it as Vp minus 4 divided by 2 kilo is equal to Vx by 4000. It is equal to Vx by 4000. That is the only thing. I have one current outgoing, the other current which is entering over there. But what is Vp? Vp is nothing but equal to Vx itself. See, this voltage is nothing but Vp I am writing, that is nothing but equal to this voltage Vx itself. So, for Vp, substitute Vx. Vp is equal to Vx, it is because no current flows through 3 kilo ohm resistor. It's, since there is no current flowing through that, there won't be any drop. Drop across this will be equal to 0. If the drop across this is equal to 0, then voltage at this point and voltage at this point are same. Since the voltage at these 2 points are same, the voltage at this point is mentioned as Vx, so that I can write Vp as Vx itself. So, substituting for Vp equal to Vx here, I am going to get it as Vx by 2k minus 4 by 2k is equal to Vx by 4k. That is 4000 or it is 4k. I can just write it like that. Or Vx by 2k minus Vx by 4k is equal to 4 by 2k. 4 by 2k. Or you can find out Vx by 4k, simplifying this equation, taking 4k as LCM over here, it is 2k 2 minus 1 Vx, so that it is Vx divided by 4k, which is equal to 4 by 2k. K you can cancel 2, so that here therefore Vx is equal to, cross multiplying this, you are going to get it as 8 volts. So, your Thevenin's equivalent voltage or open circuit voltage or whatever Vx they have asked you here is nothing but equal to 8 volts. So, we have found out the Thevenin's equivalent voltage. Next, to find out Thevenin's equivalent resistance, since I have a dependent source over here, I need to go for short circuit current calculation. So, what is short circuit current calculation? I have to short the terminals P and Q. As soon as I short the terminals P and Q, the voltage here is going to become 0. Vx is going to become 0. If Vx is 0 here, then this is also equal to 0. So, when that is equal to 0, then in this network I have only one loop. Okay. So, since I have only one loop, I can find out ISC, short circuit current, which is flowing through the terminals P and Q, which is ISC, which is equal to 4 volts divided by 2 plus 3. This part is not there. This is equal to 0. If this is equal to 0, it is like an open circuit. It is an open circuit. Since the magnitude of the current source value is equal to 0, it is an open circuit there. So, I have only one loop in the network, so that current ISC will be equal to the voltage divided by the total resistance. The total resistance here is equal to 5 kilo ohms. 2 plus 3, 5 kilo ohms. So, I have ISC value and I also have Vx, which is nothing but equal to open circuit voltage. So, using those two, I can find out R Thevenin, which is equal to, the value of R Thevenin is equal to V open circuit by I short circuit. So, open circuit voltage here is equal to 8 and the short circuit value here is equal to 4 by 5k. 4 by 5k. So, 8 into 5, 20k, 40k by 4, or it is equal to 10k. 10 kilo ohms is Thevenin's equivalent resistance. Since I have 10 kilo ohms as Thevenin's equivalent resistance, replace this circuit by Thevenin's equivalent network. So, your Thevenin's equivalent network will be consisting of a voltage source in series with an equivalent resistance. So, this is my Thevenin's equivalent circuit. V Thevenin is nothing but equal to Vx. So, it is equal to 8 volts and my R Thevenin value is equal to 10 kilo ohm. So, this is the solution for this problem. Next, moving on to the next problem, we just consider the problem number 5 itself. So, in the problem number 5 also, I am having a dependent source and an independent source. So, let me just discuss briefly about problem number 5. It is having 3 ohm resistor and then one more 3 ohm resistor I have in series with that. Then I have a current source, the value of which is equal to 10 amperes. Then I have 5 ohm resistor. Next, Vx by 4 is a current source. It's a current source which is dependent on Vx by 4, and I have to find out the voltage Thevenin's equivalent network between the terminals A and B. What is Vx in this case? The drop across 3 ohm resistor is Vx in this particular case. So now, as usual, the same procedure we have to follow, very similar analysis here. I have a dependent source or dependent current source, the magnitude of which is dependent on the drop across 3 ohm resistor. Let me just write it very clearly here. It is Vx minus plus Vx across this 3 ohm resistor is Vx. So once again, follow the same procedure. You have to find out the voltage across A and B. In order to find out the voltage across A and B, you can just write this as one node V1 and this is another node V2. We have two nodes V1 and V2 here, and this is the reference node. I can go for nodal analysis or I can go for mesh analysis. So whichever is convenient, we can use that. So now in this case, if I go for the nodal analysis, I can write the equation V1, the other voltage is a ground voltage here. So V1 minus 0 divided by the total resistance in this path is 3 plus 3, 6. V1 by 6 plus V1 minus V2. So it is V1 minus V2 by 5 is equal to 10. The current source which is connected there is 10. So this is equation number 1. The other equation I am going to write for the second node here, which is giving me V2 minus V1 by 5 is equal to Vx by 4, because this is a current source there. So I write V2 minus V1 by 5 is equal to Vx by 4. That is the one I am going to write it. But what is Vx? I need to know the value of Vx here. What is Vx? Vx is nothing but equal to V1 by 6 into 3. So just write Vx. Vx is the drop across 3 ohm resistor. How do we find out the drop across 3 ohm resistor? Just by finding out the current that is flowing through that multiplied with the value of the resistance. Current through that is nothing but equal to the voltage difference. So V1 minus 0, that is V1 divided by 6 ohm resistor. So it is V1 by 6 is the amount of current flowing through that multiplied with 3 ohm resistance. So it is V1 by 6 into 3 is the value Vx equal to. So I can just write it as V1 by 2. So substituting for Vx in this equation, I can write this equation as Vx divided by 2 into 4, it is Vx by 8. It is it is V1 by 8. It's equal to V1 by 8. So now what we have to do is solving for these two equations. Just solve equation number 1 and 2 for V2, because V2 is nothing but equal to the voltage AB. So find out V2, and that V2 which is equal to VAB, or that is equal to V Thevenin or V open circuit voltage. So find out the value V2 by using these two equations. So after finding V Thevenin, the next step is to find out R Thevenin. So to find out R Thevenin, you have to find out the short circuit current here. As soon as I short this terminal, the value of V2 here is going to become 0. Okay. So because it is connected to ground again, so that I can say V2 is equal to 0. Now apply appropriate equations, write the appropriate equations to find out the current ISC. That means by applying nodal analysis itself you can find out the current ISC. After finding the current ISC, your RThevenin value will be equal to VThevenin by ISC. So just try the problem. Every step is mentioned here. Just try the problem here. So VThevenin you can find out by using these two equations, and RThevenin just by shorting the terminals and making the value V2 here equal to 0, you can find out the short circuit current. Once both the values are known to you, find out RThevenin, which is equal to VThevenin by ISC. So that is the procedure to be followed in order to solve the Thevenin's equivalent circuit. So now the important thing is, so far we have considered only the DC circuits for solving the problem. The procedure to solve the problems using Thevenin's equivalent or by applying Thevenin's theorem remains the same, it is not going to vary, but there in case of AC circuit we will come across the complex numbers. So when we are handling the complex number, we should be careful, because sometimes the numbers are given in polar forms and sometimes the numbers are given in rectangular form. There may be the conversions from polar to rectangular and rectangular to polar, which we need to understand. That we are going to continue in our next class. Thank you.